at Narromine, so I thought I'd catch up with Uys Jonker to find out what's happening at Jonker Aircraft. In 2017, at Benalla, it was quite a remarkable World Championships. We had the very first JS3, the very first outing for the JS3, as well as the Ventus 3. It was quite an interesting time, wasn't it?
Yeah, it was an amazing period. I think for all the manufacturers, also the EB29R was the first time out. And then we saw the amazing abilities in open class that Binder developed. Also adding to the new portfolio of aircraft in the market.
Yes, and now you're developing or just announced the JS5, which is your open class glider.
Yeah, that's correct, John. Obviously, we were inspired by the EB29R. We had quite a good impact with the JS1 21 meters in open class, and it transformed the open class quite a bit and put a life in the open class, and then EB stepped it up, Binder stepped it up quite a bit to the 29R, and we internally had to decide if we would like to engage in the manufacturers contest in open class, as it's a very expensive investment, open class, and the EB29R is a brilliant product. And we did our calculations first, and we had to determine what is required for good open class, and we specified on paper on the JS5 what we think would be another contender in the open class. So we would like to keep things nice and hot in the open class.
Right, and so where are you up to with the JS5?
Well, it actually took a long time. Even before COVID, we would be ready with a aerodynamic design. But for the first time, because the open class is such a huge aircraft, that the structural limitations plays a much bigger role than it would be in the shorter wingspans. And therefore, we had to do a number of iterations, additional iterations, including the structural deficiencies or the adverse effects of the structural bending in flight. And we modeled this back into the system. So we actually did 5 iterations on the product, 5 complete iterations, structural aerodynamic iterations, test the model again, and then verify the twist and bend moments, verify or evaluate the performance then. And then we did changes and changes until a point where we thought we found the optimum sweet spot with a compromise between structure and aerodynamic performance. And this is also what determined the wingspan length, the profile thicknesses, the plan form, all were actually dictated by the limitations of the materials available.
Okay, so tell us about the aircraft. What are its specifications?
So we finally derived to a 24.2 meter wingspan with quite a high-ish wing loading. So we selected to be slightly lower than the JS3. It's a 58 wing loading, which makes it fairly light on the ground to handle for open class. So maximum weight 770 kilograms. And on the ground, it feels really light to operate. It doesn't feel like a heavy open class aircraft. If it's without water, it basically feels like an 18-meter aircraft. It's, in our opinion, quite light. Assembly of the wings are also acceptable, or you can expect that open class inner wing panels all become heavy. But it's a light glider, and flying it without water, it really feels almost like an 18-meter you're flying. It is the handling that we got with the shorter span, I think, will make a good maneuverability aircraft, or aircraft with a good maneuverability.
So you ended up with a wingspan that wasn't exact. It was 0.2 of a meter. How did that come about?
Yeah, we did not agree on a fixed round number of a wingspan, so we did iterations and we tried to find the optimum sweet spot, and it came to 24.2 meters. I also did not know what this wingspan until about when we test flew it. So it was also for me unclear what the final number was. I did not investigate that. But it's 24.2, and that is what we've thought is the highest average cross-country speeds you will obtain over weekdays and in strong days.
Okay, and what about the cockpit? Is that based on the JS1 or JS3, or is that new?
That is the JS2 cockpit. So the JS2 is a combination between the JS2 and between the JS3 and the JS1 cockpits. So we made the cockpit large enough, which we think is large enough, but still a high-performance cockpit, but with the ability to carry the self-launcher engine. So the JS2 was developed as a recreational aircraft, which will be 1821 meters, which is now completed. But we spend a lot of time to modify the fuselage that it can take both wingspans. So now the exact same fuselage can take the JS5 or it could be a JS2. And to do the interchangeability between it I think that took us a couple of years to ensure that the wings are completely interchangeable. So it's a JS2 fuselage with longer wings, which we call the JS5.
Right, okay. And when will it be available?
Well, we do the initial performance evaluation tests now. So the initial test that we are doing obviously takes a bit of time just to make sure that what we have designed performs as it is. The initial handling is absolutely astonishing, so we would like to keep the handling as it is. And then the certification process starts. So we will start with the certification process early next year. And that normally will take about 12 months. But in the meantime, we will do a short production run of about 5 aircraft to just understand the production systems, to understand if we must make any tooling changes, and to train the production organization up to produce. So I think we will push the start button probably in 12 months' time. We will go into full production.
Okay, so at World Championships in the not too distant future, we hope to see it.
And there could be a chance that it is at the Vivaldi. Obviously, some water still to be running into the sea before that, but that could be the next open class competition which we could target.
Right, okay, Uvalde in Texas, excellent. And so what about the future development of gliders? I mean, we've come a long way since the ASW20, my glider. What does the future hold, do you think? Is it, what other developments will come later?
As we always said for the last 20 years, that gliders cannot improve any longer. So that is a story that we always feared, but still designers find ways to improve. And with a new ability to use computers to aid your design with analysis software, that one can do much more iterations and you don't have to do wind tunnel tests. So we can refine models and design now on a very finer level. So we're doing now the fine tuning and obviously looking at the bigger picture. I think the design philosophy changed from looking for the best L over D, the best glide angle. Then we rather look at what is the best cross-country speed using weather models. So we see what weather model, what cross-country speed for different configurations for specific weather models, and then you use different weather models to see that it's also all-rounder in all the conditions. So I think because the design approach is slightly different, that aircraft will look a little different in the future. Not in the future, but this is why they look different from 20 years ago. There's certain aspects where developers can still extract a bit more performance out. I don't think there will be radical changes like tailless aircraft or just flying wings or with suction and things. I think there will not be massive changes in the near future. It will just be simple, small refinements. And much safer. One thing is the handling of the aircraft improved significantly and the safety aspect also a lot. So I think there's a lot of development in that aspect that doesn't translate into glide angle, but does translate into improvements in the product.
Okay. Well, we'll look forward to the JS5 and to the future. Thank you very much, Uys Jonker.